Hey everyone. Alright, this is the video to help you through the related rates homework. Um, that's section 5.6 if any of you are keeping up in the book. So we left off on number 5, and what I have written here is you have this conical mound of sand as a conveyor belt dumps all this sand onto the mound, that the volume of the mound is changing. And they tell you that in my problem, dV/dt is 9. The volume is changing 9 cubic meters per minute, I believe. Yeah, okay. And then they also give you the fact that the height is going to be 7, and they want you to find the rate at which the height is changing, which is dH dt. And they want you to find dr dt, the rate at which the radius is changing. Okay? Then they give you this relationship between the height and the diameter, but really the important thing is to get the relationship between the height and the radius, because that's what shows up in the volume equation for a cone. So the height is 3/8 the diameter, but the diameter is twice the radius. So really you end up with h is equal to 3/4 the radius. All right? Okay. So you can do this either of two ways. I can either have only r's here, or I can have only h's here. It doesn't matter. I'm going to do it with only r, because I feel it's easier that way. So if I do it with only r, I have to solve this for r, so I end up getting r is equal to 4/3 h, right? So I'm going to use that. All I did was multiply both sides of this by 4/3, the reciprocal. So let me plug that in, and I get v is equal to pi over 3 times pi over 3 times, and then plug this in, 4/3 h squared. And then there's another h out here. But this turns out to be 4/3 squared is 16/27. So pi over 3 times 16/27. H squared is just h squared, and then there's the h from out here. Alright, well this becomes, I'm sorry, this is 16/9, not 16/27. 16/9. So then this becomes 16 pi over 27. 3 times 9 is 27. And this is h cubed. That's my v. Alright, this is nice. This is much better than dealing with two variables where I'd have to use the product rule. And I knew I had to do this because they didn't give me anything with r. They didn't give me like r is equal to 5 or dr dt is equal to this. So all they told you was the relationship between r and h. So you know you have to get it down to one variable if they don't give you the numbers for the other variable. Now we take the derivative, d dt, d dt. Okay? So dv dt is going to be, bring the power down, this will simplify to 16 pi over 9 times h squared dh dt. Alright? And this is what we want to know. We don't know this, we know this, and we know this. So let's go ahead and plug everything in. So this is going to be 9 is equal to 16 pi over 9, and then h is 7 squared times dh dt. Okay, so if I simplify this, or I solve for dh dt, I'll get dh dt is equal to 81 pi over, no, not 81 pi, sorry. The pi is going to be on the bottom. So it's going to be 81 over all of whatever's on the top here. So 16 times 49 is 784. So this is 784 pi. So 81 divided by 784 pi, 784 pi is equal to 0.03287. Let's leave it off there. This is, now let's think about our units. DHDT, H was 7 meters. This is meters cubed um, per minute, right? The volume was meters cubed per minute that they gave it in. So everything's in meters. So this is going to be HDT is meters per minute. Now I'm doing this because they honestly were really not nice in this problem. But they're making you change the units because the units that the answer needs to be in is centimeters per minute. So to change from meters to centimeters, we know that we have to multiply by 100, which just means move the decimal place twice. All right, so this ends up being 3.2887 centimeters per minute, which is equal to 3.29 when I round off. All right, I really apologize for that tedious step. They should not be making you do something like that with all the other stuff that's already going on in this problem. Now, figure out dr/dt. Okay, well, dr/dt is going to be we have a relationship between r and h here, so let me just say, okay, dr/dt is going to be equal to 4/3 dh/dt. So I just multiply this answer by 4/3. 4/3 times 3.2, the not rounded off answer. Remember, don't round off till the very end. Times 4 divided by 3. So I got 4.38 centimeters per minute, which is the correct answer. So there's the two correct answers. Very not fair of them to make you change units in this problem. It's not a physics class, so nonetheless, there it is. All right, number 6. Yeah, number 6. Okay. So number 6, you have this ladder, and they already have the picture there for you, so that's nice. You have this ladder that is moving away from a wall. It's sliding down a wall, and basically you get this triangle where the top of the ladder is moving this way and the base of the ladder is moving that way. Okay? And so the big equation is going to be the hypotenuse, and you're going to have, we'll call this x, we'll call this y. So the hypotenuse s squared is equal to x squared plus y squared. That's going to be their big overarching equation. Let's see what they tell us here. It's a 13-foot ladder, so this, I'll call this s. S is equal to 13. That is a fixed number. So that'll come into play when we have to take the derivative of this, of the main equation. So by the time the base is 12 feet, so find, this is part A. Find dy dt when x is equal to 12. Okay? And they're also telling us that dx dt is equal to 15. Alright, so let's see. Let me go ahead and take the derivative of this thing. So let me write it again here. S squared is equal to x squared plus y squared. And I get d dt of this is equal to d dt of this. Okay, whoops. So that gives me 2x dx dt plus 2y dy dt. And then 2s ds dt. So you can always write this is always true, but you have to figure out which one of these is going to be 0. If I look at my picture, this is a fixed number. That means, of course, the length of the ladder itself is never going to change, which is what this is. This is the length of the ladder, which is never going to change. So this whole thing is 0. All right. So now we can say, let me move this up here. We can say that 0 is equal to 2x dx dt plus 2y dy dt. Alright, let's go ahead and solve this for dy dt. I'll subtract this over, so I'll end up getting 2y dy dt is equal to negative 2x dx dt. And then divide by 2y, so the 2's will go away, and we'll end up with dy dt is equal to negative x over y dx dt. Okay? Now, what do we know? We know this. We know this. But we do not know this. Well, what do we use for that? We use the Pythagorean theorem, which is up here. So y is going to be equal to the square root of 13 squared, yeah, 13, minus 12 squared, which gives me, which is going to end up being 5. Okay? The square root of that. So now I know what that is. So this is dy dt is equal to negative 12 over 5 times 15. So I end up getting negative 36 feet per second, which it makes sense because it's going down. Okay, so negative 36, that's part A. Alright, part B says how quickly is the area changing. So area, that was the hardest part, by the way, I think. The hardest part. The area is equal to 1/2 the base of this triangle, but what's the base? It's x. So let's write that, x, times the height of this triangle, which is y. So y. Now let's take this derivative, dA dt, and then d dt. Okay, so dA, we want the rate at which the area of the triangle is changing, is going to be 1/2 times, how do we take the derivative of this? Does this depend on time? Yes, this is moving at a certain rate. We already see that it is. Does this depend on time? Yes, it is. So we're going to have to do a product rule. So this is like my u and this is my v. So u prime v is dx dt times y, plus v prime u is dy dt times x. Thankfully, we already have all these. We have dx dt, we have y, we have dy dt. We just got it here in this part, and we have x. So let's just plug it in. 1/2 times dx dt was 15. Y turned out to be 5. dy dt is negative 36. And x is 12. Okay? If I simplify all that, I should end up with, remember, divide by 2, negative 178, sorry, 0.5 feet squared per second. Part C, how quickly is the angle changing? So now, if you're asking about angle, you have to remember, I need something that I can plug in the sides of a triangle and get back an angle. That's going to be either arc sine, arc cosine, or arc tangent. You want to think ahead when you do this. If I use arc tangent, which a lot of people like to use for these, I'm going to have y and x, and I'm going to have to take a derivative of something. Let me just write it here. If let's say I used arc tangent, then I would say theta is equal to the arc tangent of y over x. That's true.